So from this combination, see, I cannot take anything as common and continue further, right? Let me change a little bit of the combination what I have written here. So instead of this, let me group the first. Yeah, I'm just trying out the different combinations. That's all. So z square y minus x square y, I will keep it as one group, plus x z square minus z x square. Let me just try if I'm getting something common. Okay. Now from this, what is common? Y is taken common. So z square minus x square. From this, x z can be taken common. The remaining element is z minus x. And what is z square minus x square? Z minus x multiplied by z plus x. That means z minus x can be taken common. So I already have y minus x, z minus y, and now z minus x is taken common. So from this, y as it is multiplied by z plus x plus xz as it is, because z minus x is taken outside. The last is arrangement in the fashion which is required for me. So minus will be taken common, x minus y multiplied by y minus z multiplied by z minus x. Multiply this now. So zx plus yx plus xz. Fine. And just check, minus into minus will be plus x minus y, y minus z, z minus x multiplied by xy plus yz plus zx. My required arrangement. Okay, so you'll be wondering, sir, how to remember all this? No problem. Just it's a matter of practicing. That's it. You may not get it for the first time. Okay, you may not get it for the second time also. But the failures in the first time and second time will teach you a lot of things. Will teach you how to do exactly in the third trial. Okay, so not to worry when you're not getting the answer for the first time or for the second time. From those trials, you're actually learning something, and then you will go to continue. Clear? So we just need to sit and practice. That's it. Nothing else. That's the only way. Now I have become master of doing all this, even though I have done this problem so many times. I won't buy hard the things. What I did, I tried this thing. So I tried this. I'm not getting the answer. Okay. So I just left this. I tried with a different combination. So with a different combination, certainly it's possible for me to get the answer. That is what even you have to do. Sit and practice and learn. That's it. Okay. This is the only one problem of such kind which will be prolonged for a long time. Okay. It's a bit lengthier. That's all. So let's go for the next. So let's have the next one. The next are quite easier problems actually. They are not at all difficult. So in this one, compared to the first main, what was the thing? In this one, 1, 1, 1 was not there. So we tried to make it as 1, 1, 1 before going for the expansion. Correct? That's all now. So the third main, I will simply select the LHS directly. So the third one is x plus 4, 2x, 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 x plus 4, 2x, then 2x, 2x, x plus 4. Okay, write the right side to show you something actually. 5x plus 4 multiplied by 4 minus x the whole square. Sir, 1, 1, 1 is not there in a row, or it is not there in a column. We will try to make it 1, 1, 1. That is the next thing. So if it's not there, we will try to make it. If that is also not possible, we'll go for something else. That we will see it later. So in this column, we don't have 1, 1, 1. Let us try. Okay. The hint is there on the right side actually. If you can observe, 5x plus 4. Come back. Add these three. What happens? X plus 4 plus 2x plus 2x. On adding this, what is that I'm going to get? 5x plus 4. Again, add up these three, 5x plus 4. Add up these three, 5x plus 4. But if I'm adding in this way, I'm adding what? You're adding these, right? So that means we're adding columns. Columns are added. You will get confused with this actually. Not to do this. When you're adding in this way, this actually is a row. This is a row, right? But the elements are the column elements. Okay. You think if it's a horizontal, you're adding in column wise. If it's a vertical, okay, that means the element should be added in row wise. That's a way to remember. Okay. So not to get confused. So the hint is, let me consider C1 as C1 plus C2 plus C3. Sir, why not C2 or C3? Please apply. Not at all an issue. Okay, fine. And students, I will tell you the difference between the third main and the fourth main. Okay, the third main, See, you are adding it this way also, you are getting 5x plus 4. You add up this way also, you will get 5x plus 4. That means in this one, row or column, anything is fine. You add the elements in row wise, you will get the common element. You add the elements in column wise, you will still get the same common element. That means here, row or column, any operations are fine. Clear? But in the next one, it's not the same. Fourth main, you have to either only go for row or you have to only go for column. That I will tell you later. So let us start with C1. C1 has C1 plus C2 plus C3. Now that means this is my C1, right? So C1 elements is C1 element plus C2 element plus C3 element. Fine. So if I add this, it's going to be 5x plus 4. Add this, it's going to be 5x plus 4. Add these three, it will be 5x plus 4. Then what? The remaining element, 2x, x plus 4, 2x. Then 2x, 2x, x plus 4. So why the addition was done? To get the common element, that's it. Now the hint will be there somewhere on the right side, you have to observe. You will get a hint actually. Now let us take out this common element outside. So 5x plus 4, 1, 1, 1. 2x, x plus 4, 2x. Okay. The next 2x, 2x, x plus 4. So what's our main intention is, once we see 1, 1, 1, one of the 1 will be retained. The other 2 1 should be made as 0. Okay. So it's better convenient always the first one will be retained. Let me retain this. I want to go and make these 2 elements as 0. This is the leading element of R2 and this is the leading element of R3. Fine. Okay. Now what I do, R2 will be written as R2 minus R1. R3 will be written as R3 minus R2. You can go with R1 also. Remember. So 5x plus 4. No change in R1. 1, 2x, 2x. Clear? Right. The next one. 1 minus 1. 0. X plus 4 minus 2x. If you want, you can just write side by here. X plus 4 minus 2x. What you get here is 4 minus x. So here the element will be 4 minus x. And the next one, 2x minus 2x, 0. Fine? Okay. Now 1 minus 1, 0. Subtract these two. On subtraction of these two, you will actually going to get what? X minus 4. And if I subtract these two, it's going to be 4 minus x. That's okay. Now the rest is to get the required arrangement. That's it. Now let's go for the expansion. So let's retain 5x plus 4 as it is. Expansion should be done only for the first element, because if I want to expand for these two, for 2x I have to multiply these two which are zeros. Again for 2x, these two elements are going to be 0. Correct now? So only expand for the first element. 1 multiplied by 4 minus x multiplied by 4 minus x. 4 minus x the whole square. 0 multiplied by x minus 4 will be 0. Right? So what is the remaining? Finally I got it. 5x plus 4 multiplied by 4 minus x the whole square. That's my requirement. Okay, so let's move to the next one. If 1, 1, 1 is given to us, it's easy. If not, we will try to make a common element by adding rows or columns, or otherwise multiply and dividing procedure. Okay, then it's possible to take the common element outside. We'll get 1, 1, 1 and then start the procedure. So the third main, second one. So it's given as y plus k, y, 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 y plus k, y, then it is y, y, y plus k, and the right side is 3y plus k multiplied by k square. So you can observe the hint. You have to get something called as 3y plus k. Okay, now if I add these three, 3y plus k. If I add these three also, 3y plus k. That means in column number 3, either you can go for row addition or you can go for column wise addition. Previous one I went with columns. Let me try this with row. Let me add up these three. So when I am adding these three, that means I am applying row. Okay, that means my R1 will be changed. R1 will be written as R1 plus R2 plus R3. So my first row, correct now? First row, first element is this. First, second, third. All the three elements will be added. When I add up these three, that will be my first element of R1. So the addition of these three, 3y plus k. Again add up these three, 3y plus k. Again add up these three, 3y plus k. Now the next as it is, y, y, y plus k, y, and y plus k. So what is common from R1 now? The common from R1 will be 3y plus k. Now it is 1y. So 1y plus k, y. 1y, y plus k. That's okay now? Fine. Now look at this time. This time 1, 1, 1. They are the leading elements of columns. Let me retain this and let me concentrate on making these two as 0. For C2 minus C1. For C3, C3 minus C2 also I can go. But look at, there is one advantage actually. If I go with this, there is an advantage. You can go with C2 also, remember. But there is an advantage of going with C1 that I will show you later. So this will be 3y plus k. So 1y, y. No change in the first column. 1 minus 1, 0. If I subtract these two, just k. If I subtract these two, it's going to be 0. Let me go with C1. 1 minus 1, 0. Y minus y, 0. If I subtract these two, just k. What is the advantage? Look here. This we call it as principal diagonal. Above that, all the elements are 0. So, what is the property number 7 says? If one side of the principal diagonal, if all the elements are 0, okay, then the value is just the product of the principal diagonal. That means you don't go and expand it. Simply you multiply these three. That will be the value of the determinant. That was the advantage of going with C1. Previous problem also you can do the same. So let's retain 3y plus k, and the product of these three is going to be what? K square. That's the required answer, right? So in problem number 3, you can go for row wise addition or you can go for column wise addition. The elements are still going to be same. So once you get the same element, take it outside from the row or column, keep it outside. You will get 1, 1, 1. One of the one will be retained, the other two ones will be made as 0. After that, you have to think of the remaining option before expanding. Clear? So let's go for the next problem number 4. Again, two problems are there. A. So what is given as A minus B minus C, 2A, 2A. Then it's going to be 2B, B minus C, 2B. The next 2C, 2C, then C minus A minus C. That's correct? Okay. Now the right hand side is A plus B plus C, the whole cube. Unless the previous column, this column, you cannot take both the method. That means you cannot go row wise and column wise. Any one of the method will be present. That is the difference between the fourth and third and the fourth one. In third one, you go for row wise or column wise, you will get the common element. But in the fourth main, no, any one, either row wise or column wise. Let us see which one. Okay, first thing, if I am adding these three, that means I am adding these three. So vertically I am adding now. So vertically means row addition. Remember this way. Horizontal, vertically it was added, right? Now, if I am adding this, it's a horizontal, right? So horizontal means I am going for column addition. That's the way to remember. So just remember the simple trick now, you will never get confused. Okay, let me add up these three. So what is given? A minus B minus C plus 2B plus 2C. So A as it is, minus B plus 2B plus B, minus C plus 2C plus C. Correct. Again add up these three, you will still get the same A plus B plus B. Again add up these three, you will get A plus B plus C. That means, in which way I added? Added vertically. That means row addition I went for it. Let me add up these three. So I am adding these three, A minus B minus C plus 2A plus 2A. So 5A minus B minus C, but look at the right side. The right side says you have to get an element A plus B plus C. So in which way I am getting A plus B plus C? By adding row wise. That means this column is based on row wise addition, then taking common element and then going for simplification. So let me start with this part. So that's the LHS. So let's consider R1 as R1 plus R2 plus R3. So if I add up these three, I am going to get A plus B plus C. So again add up this, again add up this, A plus B plus C. Let's write down the remaining 2 rows as it is. 2b, b minus c minus a, 2b, 2c, 2c, c minus a minus b. Now notice what is common from R1, a plus b plus c. Let's keep it outside. A plus b plus c. So it's 1, 2b, 2c, 1, b minus c minus a, 2c, 1, 2b, c minus a minus b. Common element removed. Then 1, 1, 1. As I said, 1, 1, 1 is present, but they are the leading elements of C1, C2, C3. Correct, right? So if I want to make this as 0, I should apply an operation for C2. If I want to make this as 0, I should apply an operation for C3. So C2 will be written as C2 minus C1. C3 will be written as C3 minus, go with C1. There is an advantage once again. Okay. Now the common element already is A plus B plus C. So 1, 2B and 2C. Let's see this. 1 minus 1, 0. I want to subtract these two. What happens if I subtract these two? B minus C minus A minus 2. Sorry, minus 2B. Correct now? Okay, look here. B minus 2B minus B minus C minus A. If I take minus common, clear? Hope it's fine, students. Okay. Now, so that's what. Whenever you get such kind of calculation, you do it in the side by of the problem and just put it back. So here minus of A plus B plus C. Now 2C minus 2C, 0. 1 minus 1, 0. 2B minus 2B, 0. If I subtract these two, subtract and check, you will going to get minus of A plus B plus C. What is the advantage of going C3 with C1? One side of the principal diagonal, all the elements are 0, then the value is the product of the principal diagonal. You no need to expand also, correct now? So it is A plus B plus C. If I multiply these three, what I am going to get? A plus B plus C, the whole square. So finally multiply this, A plus B plus C, the whole.